Welcome all. Welcome to this lecture of object-oriented programming. Today we'll start with a new unit, Unit 6, that is exception handling, input-output, abstract classes, and interfaces. Okay. So let me show the disclaimer, then I'll start the session. Okay. So let's start with Unit 6. Okay. Uh, what is exception handling basically? So, see, exception handling is very much useful. Kind of. It's a kind of useful. We can say API or simply a useful feature of Java language, such that it helps us to deal with exceptional situations and continue its normal execution of the program. So many times what happens, program, there is a let's say from a program execution starts with step A and ends at step let's say Z, right? So this is, let's say, a normal program execution. But what if in between the program execution stops and it exits out, right? So that is abnormal or exceptional situation. Right. So in order to continue back, continue back from this particular location, or continue back from wherever possible, like it can be possible from here or in that way. So in order to continue its normal execution, right? It's better to use what? Exception handling. What happens is when you have this kind of sequence and in between the control exits, right? Let's say control exits in between due to an exception or due to an error. So what we can do is we can handle it out, and then again the control can be sent back to the next instruction. Okay. And for this particular instance, a message or something would be given to the user, right? So that is exception handling. It does not, it does not make the program uh, what? It does not make the program break at any point. So it allows you to control the execution of the program. Okay. Now the runtime errors occur while a program is, see, there are runtime errors also sometimes which occur while program is running. If JVM detects an operation that is impossible to carry out, for example, any number divided by 0, if I say number 5 divided by 0, so this is, we know that it's an infinite value, right? So this is not possible. So this is impossible to carry out for the JVM, right? This operation is impossible to carry out. So that's why in that case the runtime errors would occur. And thus the runtime errors are thrown as what? The JVM throws it as an exception, saying that this is an exceptional situation, it's abnormal situation, and the program cannot continue, right? So we can catch it. Java allows us to catch it and handle it. Okay. So how do we catch it? In the form of an exception, which is nothing but an object. Java deals with objects, so the exception, the error itself is converted into an object and is can be caught by our program. Okay. So exception is an object that represents an error or a condition that prevents execution normally. Okay, a condition that prevents normal execution of the program, right? So what we do, we handle the exception, right? So if the exception is not handled, the program will terminate abnormally. Program will terminate abnormally. Okay. So see, exceptions are normally thrown from a method. Okay, because we write all the code inside the method, right? We don't write any expression code or something, any assignment code or any decision statement or any input output statements outside the methods, right? We don't do that. So that's why exceptions are normally thrown from a method, and the caller of the method can catch and handle the exception. The method which calls the method, that particular method, can catch the exception. So it's something like this. You have a method 1, right, which is being executed, and let's say it ends over here, and method 1 at some point calls method 2, right? A method 2 call is given. So the method 2 is something like this. And what happens is, from here the control comes over here and it executes, and let's say at this point it breaks. What happens is, the exception is generated at this point. So what will happen is, it will not continue its further execution. What will happen is, the control will be thrown back from here to the calling method. Okay, so the calling method should handle this exception. So basically it is better to handle the exception over here only, so that what can happen is you can continue your execution, right? If that is not possible, then you declare that this method can throw an exception. So the method call to method 2 in method 1, this is method call to method 2, right? This is the call to method 2, which is written in method 1. So method 1 is the calling method. Okay, method 1 is what? Method 1 is the calling method, and method 2 is the called method, right? So if the called method is throwing an exception at some point, then it can declare that it just throws the exception. That can be declared inside its signature itself. Okay. And if it's declared, then method 1 will have to handle it. Okay. Or it's better that method 1 handles this call using exception handling techniques. Okay. Otherwise, what would happen? Otherwise, the control gets returned from here, which is due to exception, and instead of this execution of method 1 continuing, that also stops. So from there from there also the control exits. Due to what? Due to exception, because method 1 was not able to handle the exception. Method 1 was not able to handle the exception, so it should also not continue the execution. It's as simple as that. So if an exception gets generated, you can see it affects the whole hierarchy of calling. Method 1 suppose is called, then method 2 is called. So if method 2 does not execute, it generates the exception, it is sent to method 2, and method 2 cannot continue executing. So this is the biggest problem of what? Of exceptions or runtime errors. So in order to do this, in order to do a normal execution after an exception is caught, right, we use exception handling technique. Okay, so how do we use it? We use it, see, check this out. This is an example given over here. Inside this main method, we use a scanner object. Then we get two numbers. We get two input integer numbers. We get two integer numbers into the what? We get two integer numbers into the from the user. Then we say what? We are dividing both the numbers, and the result is number 1 divided by number 2. Now what if user enters over here a 0 value in number 2? So if user enters 20 just like this, one is entered as 3, another is entered as 0. So what will it do? It will throw an exception. It will generate an exception, and it will say exception in thread main Main is, see, every method, there is a thread created for every method, okay? So for this main method also a thread is created, and that is called as a main thread. So in that thread, arithmetic exception has occurred. Which class has been used to create the object for that exception? The class is in java.lang package, that is specifically arithmetic exception class. And what is the reason for it? Divide by 0, that is the operation that has been done, which is the reason for generating the exception. And then it shows that inside this, see, this is a quotient class, right? Class name, and let's suppose the file name is also quotient. So here it says the quotient dot mains, quotient class inside which the main method is there, and this is available in quotient.java file at line number 11. So at line number 11, the exception occurred. So if you see, this will be the line number 11. This number 1 divided by number 2, this statement would be on line number 11. Okay, and that's why it says that on line number 11, the error occurred. What does it say? That in quotient.java file, on line number 11, in this file, on this line number, the error has occurred. You know, so it's pretty easy to catch the error where the error had occurred, right? And what is the solution for this? Whatever code you want to put, right? Whatever code you want to put, where we know that an exception might get generated. For example, this is the location where the exception might get generated if the user enters wrong numbers, right? Then, so what to do? To put that code inside try catch block. That is the solution. To put the code inside the try catch block. So here you put the code where you feel that the exception would be generated. So as soon as the exception gets generated, it gets thrown and it gets caught in this catch statement. Now, whatever type of exception that it was generated, accordingly, that type of exception object can be caught over here. Okay, in the catch statement. So if you feel there will be multiple types of exceptions that may be generated, then you can put this code into try catch block, and you can have multiple catch blocks also. So see, here is the example given. Now see, this quotient part has been put into a method, static method, which returns an integer value. Name is quotient, takes two numbers, checks if number 2 is equal to 0. See, there is no issue in dividing a 0 by any number. So if number 1 is 0, there is no issue. But if number 2 is 0, then what we need to do? We need to throw so we specifically throw a new exception. See, this is how we throw. Throw new arithmetic exception, divisor cannot be 0. So number 2 cannot be 0, that's what we say. Okay, so we give the messages divisor cannot be 0. And what do we do now? See, we put this inside this main method. Inside the main method, we ask for, using the scanner object, we ask for two integers to the user and read it out from the console. Okay, and then we call this quotient method where we pass these two numbers that we had read over here. Okay, these two numbers are being passed, and then if the user had entered number 2 as 0, then it would generate an exception. So instead of returning the result over here, what would it do? Instead of doing this, the control would directly come back from here from this point. The control would be directly thrown. So see, on seeing this quotient, the control from here jumps to the method, right? And let's say the number entered by the user is 5, and number 1 is 5, and number 2 is 0. So what happens? As soon as it comes over here, it sees number 2 is 0, and from here itself, it does not even return, right? From here itself, the control gets thrown and now it does not go to this next line. No, it's not like it goes to the next line. No, that's not what is happening. What it does is, from here the control gets directly thrown, right, and it directly gets caught in this catch exception. So this statement after this int result equal to this line, this also does not get executed. You know, the system.out.println statement also does not get executed, and directly the control goes to this catch statement. And inside it, whatever the object that was created, here we are explicitly creating an arithmetic exception, so that arithmetic exception object is caught over here. It is almost equivalent to an assignment operation being done. Here you are generating the object, and here you are doing what? Here you are catching it. Okay. And then you do what? And then you simply display that this is the exception, an integer cannot be divided by 0. That's what you display. As simple as that. Right? And you also display the exception, this is the execution continues. Sorry, not the exception, but the execution continues. Right? So see, if you enter something like this, number is 5, first number is 5, second is 0, then it prints that exception is that an integer cannot be divided by 0. So see, this is a understandable or valid message. This is a valid message that can be understood by any person, right? And then we say execution continues. Then we say execution continues. Okay. So you see, it's a normal execution. Even though user entered 5 and 0, the execution, but it did not do the division operation because it was not possible, right? So it did not stop abruptly. That's the advantage of try catch. Got the point? Okay. What does the thread mean? Okay, Harshit. The threading will be taken when we see the multiple threads, multi-threading concept of Java. At that time, you will come to know about threading. Okay. So basically, just right now assume that whenever a method executes, let's say we have this, this is a class A. Okay, and it has got a public static void main method. Okay. Inside there, some code is there, let's say. Right. And here the class A ends. Okay. And there is some method, let's say, which is called, let's say, which is public static void, or simply static, let's say, static void method A. Okay, let's suppose it has got method A, and inside that, at some point, the exception gets thrown or something happens. Okay, code is there, right? So now see what happens when you basically run this class A. What happens when you say Java C and A dot Java? You get the output as what? You get the output as A dot class, right? So you get the class file after compilation. Now you have to execute it, right? So what do you say? You say Java and A, right? So you give the class name. So this is how you execute it. But once you execute, so what happens basically? What happens when you execute a class? So in order to execute a class on the console, you need what? You need a main method, right? And in order to run the main method, what does this do? This Java command will invoke what? It will invoke the JVM, right? Which it will load this A object into what? Into the Java runtime environment, right? This A will be loaded into this Java runtime environment, and inside Java runtime environment, it executes the threads. Okay, So there is a thread created for what? For basically the main method. Okay. So this whole thread is executed. Now multi-threading concept says that if a main method is executing at the simultaneously at the same time, method A can also execute. So see, normally what happens is, normally when you call this method A over here, right, the control gets transferred, control gets transferred from this method A, from this main method, from here this main method, the control gets transferred to method A. Then method A, so what happens, see, up to now this main method executes, then the control gets transferred, then method A stops executing, and then the control gets transferred back to the next location or the same location of method A, and then the rest of the program or rest of the main method executes. Got the point? This is sequential execution. This is what? This is simply the sequential execution. Okay. Main method is executing. Method A is called. The control gets transferred. That method gets stops it executes. When it stops executing, the control returns, and main method continues. So see, main method is executed. Now the thread, it gets transferred to what? To method A. This thread gets transferred to method A, and the thread executes over there. Okay. And then the control returns, and this execution of main continues and stops at some point. Okay. This is what happens. But we don't want, if we don't want this thing to happen, the sequence and execution, we might want what? We might say that the main execution also happens. Okay, we can say that main execution also happens and parallelly the method A execution also happens. So you don't need to return the control back. As soon as from this point, as soon as the control, a new thread is spawned for method A, the older thread of main method continues. You see that? So that is multi-threading. That is multi-threading concept. We will see that when we see the multi-threading concept of Java. Okay? Got the point? Yes, Arshit? We'll learn how multiple threads work. Okay? Great. Okay. So now exceptions. We saw that this is try catch is something which can help us, handle the exceptions. Now the advantage of handling exceptions is what? It enables to, exception handling has something called as, you can explicitly throw an exception. So it allows a method to explicitly throw an exception to its caller, enabling the caller method to handle the exception. And without this capability, the called method itself must handle the exception or terminate the program. But often the called method does not know what to do in case of error. So, and now see, exceptions are objects. Okay, and objects are defined using classes. So, the root class for all the exceptions is throwable class. Java.lang.throwable. Okay. So throwable class is the root of all exception classes. There is a hierarchy of all exception classes, and in which throwable class is the root class. And all other Java exception classes inherit directly or indirectly from the throwable class. Okay, and you can create your own exception class also by extending either exception or that is all making a subclass of exception, or by using this throwable. Okay, see, this is it. Object class inherited by throwable, which is inherited by exception and error. So exception is something that we can handle. Exception is something that we should handle, and error is something that we should not handle. Error is something that we should not handle, right? Like virtual machine error, Java virtual machine error, we cannot handle that, or some linkage error, right? So these are some of the errors that we should not catch, in fact. Okay, because the situation is such that due to which the error would have been generated, which is not at all controllable. Okay, and if you talk about normal, errors, normal errors like class not found, input output issues, runtime issues like arithmetic exception, null pointer means an object, you are asking for a reference to invoke an object method, but the object itself is not created. So the reference is pointing to null, it's not pointing to any object. So null pointer exception gets generated. Illegal index out of bounds except you try to access an index of an array that does not exist, or you try to send an illegal argument to a method, right? So all these kind of are these are exception classes which inherit runtime exception, which along with other exceptions like class not found, IO exception, inherit from exception class. So this exception part is what we need to handle. Okay, exception class is what we need to handle. Got the point? So see, system errors are thrown by JVM and are represented in the error class. And error class very rarely occur, like linkage error, virtual machine error. So it's not suggested to handle it. Okay. We in fact cannot handle it. If there is a virtual machine error, then obviously the program itself will stop. Then there can be exceptions which are, you know, acceptable or handleable exceptions. So the exceptions are represented by exception class, which describes errors caused by the program or logic or maybe some external circumstances. Okay. External circumstances means like maybe the class, external class which we are referring is not available, or your IO exception may occur when you are referring to a file that is not available or something like that, Now see, these are some of the exception types that we regularly use, like class not found exception. You to try to attempt a class that does not exist, then it gives you class not found exception. Okay. Then you say IO exception. IO exception is related to input output operations, such as there is an invalid input, or maybe you are reading past the end of a file. You are trying to read the file, but the file is already ended. Okay. Uh, you are trying to open a non-existent file. Right? All this come under IO exception. Okay. So we saw class not found exception and IO exception. Then arithmetic exception is there. When you divide an integer by 0, it generates an arithmetic exception. Then a null pointer exception. So it's like something like this. When you say string str, now you say is equal to null. You have not yet created any object. And now you try to say str dot length to try to access its issue. Why this would create the issue? Because you're trying to access an object to a reference that points to null. The reference is not pointing to any object yet. Okay. So that's why from that null pointer exception we come to know that okay, the reference is not yet initialized or is not yet pointing to any object, right? Then we have index out of bounds. If you try to access an index of an array which is out of the range, so if the array range is, suppose you have declared an array range int arr array range to be of 10, 10, right? And now you say ARR of 20, let's say, is equal to some value. Well, this will give you what? This will give you exception, which is what? Index out of bounds exception. Because legal indices over here are 0 to 9. And then you have what? After this you have illegal argument exception, where basically a method is passed an argument that is illegal or inappropriate. Okay. So these are the exception types that need to be caught. Okay, these need to be caught. Anyhow, you have to catch it. If you don't, and the compiler sees that there is a probability of this kind of exception being thrown, or you are calling a method that declares that it throws any of these exception types, then you need to handle that method call in a try catch block. That is compulsory. Okay. But if you see runtime exceptions, then runtime exceptions are such that runtime exceptions are basically called as what? Runtime exceptions are called as unchecked exceptions. Unchecked exceptions mean these are not checked during the compile time. Even if you throw a runtime exception explicitly, right, it doesn't create a specific issue because it's a runtime exception, it's an unchecked exception. Okay, so it means that the compiler forces the programmer to check and deal with them in a try catch block or declare it in a method header. What? Checked exception. Checked exceptions are the ones, I think there is an issue. Okay, so see the checked exceptions, these are the checked exceptions. Which are the checked exceptions? These class not found, IO exception, arithmetic exception, null pointer exception, index out of bounds exception, illegal argument exception. These all are checked exception. What are these? These are exceptions. Any that. Okay. So unchecked exceptions, see these are runtime exception. What is runtime exception? Runtime exceptions are unchecked exceptions. Specifically what? Runtime and error. These are what? Unchecked exceptions. So these reflect programming logic errors that are unrecoverable. And since these are logic errors that should be corrected in the program, so it it allows it to happen so that it gets caught into the testing part. Okay. And so it is possible, see, for example, it is possible for your program to throw an exception explicitly using the throw statement, like throw and the object, the throwable instance object. Okay, a throwable object. So this throw keyword is used to explicitly throw an exception. Okay. And what happens if once you throw an exception, the flow of execution, the flow of execution stops immediately after you throw the state. You execute the throw statement. Any subsequent statements after it are not executed. The statements after the throw statement are not executed inside the method, right? And the nearest enclosing try block is inspected when this happens. The nearest enclosing try block is inspected to see if it has a catch statement that matches the type of okay. And we can use throw to throw the unchecked exception also. like the runtime exception. Okay. So see, it might happen sometimes. It's like this: that method one code, then method two is having some code. Similarly, we have method 3 having this some code. Now see, from method 1 you are calling method 2. The control execute, method 2 executes and it has got method 3 call, right? So method 2 executes and it calls method 3 at this point. Method 3 executes and it returns the control at this point. So method 2 continues executing, then it returns the control to method 1 and then the method 1 executes. This is the normal scenario what happens, right? If method 1 is calling method 2 and method 2 is calling method 3, part 1 to method 2 executes up to method 3 call, then okay, this is then method 3 executes, the control returns back from method 3, then method 2 continues, and then control returns. Once it finishes, control returns from method 2, and then the method 1 executes or completes the execution. So this is the regular or normal scenario that happens. Yes. Now what if at some point like this, okay, at some point like this over here the exception occurs. What happens when the exception occurs? So see, the JVM sees that is there any try catch block put. So if there is no try catch block over here, try over here, and catch block over here, it stops executing at this point. And control directly goes back from this point itself, whether there is any try catch block over here, or not. If there is any try catch block, then the exception goes over there and is caught over there. If not, then again this execution does not continue, and from this point itself the control returns back. This does not continue in method 2, and this part also does not continue in method 3 due to exception. And when the control try catch block is put or not, that exception would be directly from here, it will be caught in this catch. Now it has to make sure that the type of the exception that was generated over here class type, otherwise it would not even catch the situation remains same. That is, from here the method 1 execution stops and the rest of the part of the method 1 does not get executed. It's as simple as that, you see. So you have to make sure that the nearest, which is the nearest try catch. So for the exception being occurring in method 1, the nearest try catch is provided in method 1. Got the point? How exception, disrupts the execution or stops the execution. Yes, how it can stop the execution. And if you would have, handled it properly, if the type of the class of which the exception occurred over here is same as what you have caught, then what would happen from here? The exception would be caught, and then the rest of the program would have been executed properly. As simple as that. Right? That is that's why we need to catch exceptions, so that the rest of the program execution happens properly. So you can explicitly throw. See, we learned which keywords in this. We saw try, catch. Now there are other keywords also like throw, throws. Okay, throw and throws are two different keywords available in this exception handling mechanism. And the final keyword is finally. We'll see what is that. So we'll see it soon. Okay. So the throw keyword is used to explicitly throw the exception. Right? There might be situations where you need to explicitly throw the exception. So this example was an explicit use of throwing the exception. Here inside the main method, what do? We read two numbers from the user, pass those two numbers to the quotient method, and inside the quotient method, what do? Inside the quotient method, we check if the number 2 is 0, then we explicitly throw the new arithmetic exception. We explicitly create it by saying throw new. So see, since this exception is an object, we need to create it, right? So we use new operator to create it, and we say throw new this arithmetic exception object. So from here itself, the control gets thrown, and it does not come at this place. No, it goes to this catch statement. Okay. Directly the exception gets caught, and you can see here the data type is same. Here the class type is same as the object type. Okay, so there is no issue in that. Understand the meaning of throw? Then comes throws. Now what does this throws means? So there might be some instances when you want, when you know that an exception is going to be thrown from this method, there is a full chance of an exception getting thrown. So but you don't want to handle that exception in a try catch block. Then what do? Then you use throws keyword. What do you use? Then you use the throws keyword, right? So if a method is capable of causing an exception that it does not handle or it cannot handle, right, then it must specifically specify this behavior to the callers of that method, so that the callers of the method can guard themselves against that exception. Okay, so it's like something like this. See, when you say that I have a method 1, right, and there is a method 2 also, right? This is for method 1, this is for method 2, and then this closes, it closes, and now see, we suppose that method 2 is able to throw an exception. We know that we are doing something like this. Int I is equal to 5 divided by 0. So what do we know? We know that this method is seriously going to throw an exception. It's surely going to throw an exception. So we can declare it that it throws an arithmetic exception. That can be declared. And since if it is declared, then even if it is a checked exception, you don't need to put that checked exception into try catch block. Okay. And So see, this generates an runtime exception which does not gets detected during compile time. So that's why it is called as a runtime exception. And so we need to handle it using try catch block. Okay. So we know that either it generates like this, or we are throwing new exception, saying like throw new arithmetic exception in bracket divide by 0 not possible. So you are doing what? You are saying throw a new exception, and this is the message of the arithmetic exception. Either you generate it or you explicitly throw it. Okay. We are specifically throwing an arithmetic exception. So we simply declare it that this method throws an arithmetic exception. So basically, method to call. Here you may dot out dot println exception e object e. Either you print it out or you say e dot get message. So what happens? Control comes over here, executes method 1. From here the control goes over here. Here it sees at this location. Let's suppose this is not the case. Here it sees that it is explicit, comes back over here and is caught over here. And then this executes. So there is no issue at all. Okay. And here what happens? Here since you are declaring that this method throws arithmetic exception, you need to put it in the try catch block. Otherwise, if you don't declare it, then there is a chance that method 1 may not put this method to call inside try catch block, and it might happen that the execution that stopped of method 2, right, the execution that stopped from here for method 2, that might even affect the execution of method 1. That might even stop method 1 executing further. That's why there is something called as throw and throws keyword. So we know how to use throw to throw a new exception, but how to use throws? Throws is, see, here it is declared. If there is a method that can throw an exception, so it is declared like this. See, return type of the method, and then the method name comes, then the parameter list comes. Right after that, you define what? Throws exception list. So you can define various exception. You can define your various exception classes, of which there is a probability of exception getting thrown from this body of this method. So here, see, example is given. You say public void my method throws IO exception. So we say that there is a chance of IO exception getting thrown from my method. And IO exception is of what type of exception? It's basically a checked exception. Right. Since it's a checked exception, since this IO exception is a checked exception, it needs to be caught inside try catch. Otherwise, the program will itself not get compiled. So that's why it is called as checked exception, because it does not allow the program to get compiled if it is not being handled. Okay. So see, these are the various exceptions. We saw arithmetic exception, array index out of bounds, then array store exception is there, which assignment to an array element of an incompatible type. You are trying to assign an element to an array which is not possible inside that array. Class cast exception, you are trying to do an invalid casting of an object to an invalid class. Illegal argument exception we saw. There are others also like illegal monitor state, illegal monitor operations such as waiting on unlocked thread. So this is related to threading. Illegal state exception again related to environmental application state. Illegal thread state again related to threading. Index out of bounds exception, try to access index out of bounds of the array. Negative array size exception, an array is created with a negative size. This creates an exception. Null pointer exceptions, you try to use a null reference, a reference that points to null but does not point to any object. Number format exception, that you try to convert a string to a numeric format, but that is an invalid conversion, right? Then gets generated number format exception. Uses security exception when someone tries to violate the security. String index out of bounds, you try to access an index that is out of the bounds of the string. So if a string is of length 5 and you are trying to access the index on location 6, that is not possible. And unsupported operation exception, and unsupported operation was encountered, right? So these are some of the exceptions, which are basically what? These are the unchecked exceptions. What are these? These are the unchecked exceptions. So since these are unchecked exceptions, these need to be caught in the try catch block. Okay. These needs to be caught inside the try catch block. And these are also other checked exceptions, like class not found exception. You are trying to create an object from a class that does not exist. Cloning not supported. You are trying to attempt to clone an object that does not implement the clonable interface. An illegal access exception. You are trying to access a class that is denied. Instantiation exception. You are trying to create an object of an abstract or class or an interface. You see, abstract class or interface cannot be instantiated. So if you're trying to instantiate that particular abstract class, then this might give you instantiation exception. Uninterrupted exception. So one thread has been interrupted by another thread, that is, again, you see it is related to threading. And no such field exception. You're trying to access a field that does not exist inside a object. And similarly, if you are trying to access on a method that does not exist, then it is no such method exception. Okay, so I think that's it for today. Let's call it the end of the day over here. Okay, and we'll see some more things. We'll see some more examples. Okay, the next time. All right, if it all end out, please do let me know. Okay, any doubt related to this, please do ask me. Okay, let's stop the recording now.